Another video. So on the quiz, we're going to go over this more. We're going to talk about the normal distribution, and I'm going to send you out a PowerPoint about that, and I'm going to talk about it in another video. But for the sake of your quiz, let me give you some insight here. This is a normal distribution, or it's called a Z distribution, or a Gaussian curve. We know this occurs in nature naturally, so we're going to use this a lot in statistics. A Z distribution is going to have a mean of 0. So it'll have a mean of 0, and it'll have a standard deviation of 1. So each standard deviation is going to make up 99.9% of this total distribution. Now I'm going to start assigning values to this. 68.59, I believe, is what the book says. 13 point, I can't remember. Let me see if I can get that. It's 13.5 or something like that. And of course I don't have it here. So let's just for class sake, 68, 13.5, 2.5, and 0.1. 68 and 68 is, or I'm sorry, that's where I'm messing up. 34%. Jeez. So these are percentages, and we're going to call these percentages under the curve. So I've got 34%, 13%, and 0.1%, or 1/10%. So as this curve drops down, and from your frequency distributions, this is a frequency distribution. It is normally distributed. That means from this side of the mean, median, and mode, we've got 50%. And on this side of the mean, median, and mode, I've got 50%. So what I'm going to ask you to do in your homework is I want to know what the area under the normal curve is for some value of Z. So if I ask you what is the area left of a Z value of 0, your answer would be 50%, because 0 is at the mean. So if I ask you what is the probability of a Z value of less than 0, so a Z value less than 0, you're going to tell me that's equal to 50%, because 50% lies less than 0. So the Z value less than that is 0. So if I ask you what the probability of a Z value that's less than 1, that's going to be 50 plus 34, so it'd be 85%. So 85 would be the probability. What is the probability of the area under this normal curve at some value of Z? Now I'm going to show you how to read these charts in a minute too. So let's say that I ask you what the probability of a Z-score, what's the probability of a Z-score that is between a Z value of -1 and 1. So you would just say it is 68%, because I'm going to add these two things together. So that's going to be 68%. Those are pretty easy. Now, what if I ask you what a Z value, what is the probability of the area under the normal curve for some value of a Z value between -2.5 and 0.5. So now I got to do something else. I can't just guesstimate on these things, because as you can see how this curve drops off, if I cut this in half and say, oh, there's half of the percentage here. It's not true because there's more on this half because of the peak. And the peak is called a leptokurtosis. When it gets flatter, it's called platokurtosis. We'll go over that a little later on. But now I have to use what's called a Z-chart. In the Z-chart, it will look just like this. So this should be in your book. It's in the back of your book. And it gives you Z values. Now think of a Z value as a standard deviation. So these are standard deviations. I got one standard deviation from the mean. So if I say plus and minus one standard deviation, that encompasses 68% of the area under this normal curve. If I go plus and minus two standard deviations, it will incorporate 95% of the area under the normal curve. And if I go out 3 and I say plus and minus 3 standard deviations, it's going to make up 99.7%. That's called the empirical rule. Plus and minus 1 is 68, plus and minus 2 is 95, and plus and minus 3 is 99.7. So we'll use that every time we use a Z distribution. So I asked negative 0.5. So the first thing I probably want to do is look at this area to the left of Z of 0.5. So 0.5 is going to be right here in the middle. And how I know that, I'm going to come over here to Z. I don't have anything here. I don't have I don't have like a 1. So I've got a 0.5. So I'll look over here at 0.5, which is right here, and I don't have any decimals after that. So 0.5 is going to have an area left of that Z value of 0.6915. So this one is going to be 69.15. That is the total area left of that Z value. But now I got to find out what the Z value is left of negative 2.5. So now I have to go and look up that. So the area of negative 2.5, I can look at this chart right here, it's table E, and now I've got negative numbers of Z, and I ask for 2.5. I come down here and I found it. So now I don't have any decimals. So 2.5 is going to be 0.0062. So 0.0062, or about 6/100ths of a percent. So not much at all. So there's very little beyond this point. So how I'm going to figure this out, I want to know what the Z value, or what the area is between these two values here. So all the stuff in here. So how do I find that out? Well, I got to get rid of this amount, because this it takes in everything. So if I subtract this amount from this, so I got 0.00, whoops, I don't know why I did that, 0.0062, I'm just going to subtract those two numbers. When I do that, I'll get a value of 0.6915 minus 0.0062 gives me a value of 0.69, or 69%. So all the area between this Z value of 0.5 standard deviations and this value of negative 2.5 standard deviations, all that area, that accounts for 69% of that total 100% of the distribution of scores.